Hey 10th grade, welcome to the fifth part and the final part of this week's work. We're going to include the buzzer into your schematic. I hope this week has been pretty easy for a lot of you guys because the reality is everything I'm showing you, with the exception of our temperature sensor, which was not all that difficult, you've done before, and you're really just trying to put together what you've learned to make one big electrical device. We're going to go ahead and start by putting this buzzer into row 27 because there are no other electrical components there. It's important that you rotate the buzzer and make it so that both legs are on different sides of row 27. The next step is to find out which side is negative by hovering over like this, and which side is positive. The negative side needs to be grounded, so I'll just go ahead and borrow this ground rail here like so. The positive side will be a bit trickier, as you'll need to power it with one of your remaining pins. So I'm going to go ahead and use pin 10, and I'll go ahead and put it right in there. I'm going to change this one to white, so it's easier to see. Okay, but of course, I'm going to put it on the correct side of the board so that I can actually carry a current. So now white, or this power cord, goes to positive, and negative, this one goes to ground. Now that the buzzer is put in place, all that's left to do is code it. So for the coding, the first thing I want to make sure I do is initialize this new pin I've used, pin 10. Doing that is easy. I just do another pin mode for the pin I'm using, 10, and make it an output. The last thing I want to do is going to be a little trickier, as I'm going to start using something we used only briefly, which is for loops, and I'm going to use if statements within this present if statement. So the first if statement here is if the button is pushed. Now we need a new if statement. When the button is pushed, it's going to print the results, and then it's going to do something else depending on what it gets. So it's going to say if, and then I'm going to put the condition, and the conditions will be that the distance is less than or equal to, and remember that it has to be 6 feet. The problem right now is that our distance is printed purely in inches, so we want to change to feet. So we're going to take dist and divide it by 12. Because if I have 60 inches divided by 12, I get to 5. That would be 5 feet. So it changes to feet. So now that distance is there, I want to do it here too. So if distance divided by 12 is less than or equal to 6, and this tells us if someone was in 6 feet, then I want the buzzer to ring. Now we're going to start coding what will happen with it's within 6 feet. So to do that, we use 2 squiggly brackets. I'm going to make a little room. I'm going to say what happens. I'm going to play a tone. I'm going to play it in pin 10. And I want to play it at a relatively high pitch, so that way everyone can know it's a squeaky noise. Because if it was a low bass, they might think it's something else. So I'm going to say roughly 350. And I want to play it for, let's say, a quarter of a second. The real problem is I want to do this 4 times. So in order to do this, I'm going to do a for loop. So I'm going to say for, and then I'm going to say int I, semicolon. I is less than or equal to, and I'm going to say 3. So that way it'll happen 3 times. And then I'm going to write I++, which means it goes up by 1 every time. So this way it will print for a total of, I have to say for int I equal to 1. So this way it will happen a total of 3 times. Then I'm going to include the curly brackets. I'm going to include my tone. And then I also want to include a delay in order to make sure it sounds like a musical note instead of just playing them one after the other. So usually the best way to do this is to take 1.3 and multiply it by the length of your beat. So in that case, it's 250. So what this will do is this will play a couple of quick notes, just 3 times, beep, 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 if someone is within 6 feet of me. And that's perfect because if I'm near someone and I press it and it goes beep, 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 then I can just tell them that it's me telling them they're 6 feet away. And it's not too annoying, but obnoxious enough that they'll listen to it. Okay, now I need one more if statement for a very similar result, except this time for the temperature. So I'm going to go ahead and copy my if statement. I'm going to change the distance divided by 12 to just be temp f. And I'm going to say if they're greater than or equal to, because I want them to be hotter than this temperature. And I'm going to say 98, let's say, yeah, 98 degrees should be about right. And that's how I would know if they had like a fever or running hot. Then I'm going to have the same thing, the same tone, but instead of 350, I'm going to make this one a lower tone. So I'm going to say like 250. And it will also play 3 times. Now I've set up 2 if statements. One for the buzzer, if my distance is less than 6 inches, and one for the buzzer if my temperature is super hot. Let's go ahead and test them both. If you're wearing headphones, you may want to turn down the volume to make sure it's not super annoying for you, but here we go. So my sim is running. I'm going to start with just this one. So my temperature is going to be very cold, and my distance sensor is going to be within 6 feet. 6 feet is 72 inches, so I'll put myself at 70 inches. Now when I press the button, we should hear the buzzer go 3 times. And there it is. Beep, beep, beep. 3 quick ones. So I know that the distance is 5.81 feet, and that one works. So now to make sure it still works the way it should, I'm going to put the distance sensor out and hit the button, and I should hear no buzzer. So there's my change, but no buzzer. And now the temperature. So if the temperature is too hot and I hit the buzzer, and it plays a lower tone, beep, 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 3 times. So I have 2 separate tones from this buzzer, one for the temperature and one for the distance, and both tell me how I'm doing. Okay, and with that, the device is made. This is the whole thing. Now all that's left for you to do is actually physically build it. You can take the components out of your kit, put them into a breadboard, start to place them together, and then when you've got your code, you can download it and actually make it work. Remember that for the extra credit project, you don't actually have to download the code to the board just yet, but you do need to show me that you've made a physical form of what the board looks like. If you're struggling with that, you can always text me, email me, or call me in Zoom, or ask in office hours, and I'll show you. One thing I'll point out is that the temperature detector is not super obvious when you look into your kit, but on the inside of the plastic case, it tells you what each device is, and it lists it with a picture. So you can find it pretty quickly if you use that, and then you'll find the temperature sensor right away. All right, well, I really hope this quarter has been great for you guys, because I know that it's been really something interesting for me. I look forward to what we make in quarter 4 when we finally put this together for our own exhibition and design cases for it. But other than that, that's the end. You're done for the week. So I'll see you next quarter. Have a great break.